Hello everyone, welcome to our channel Mathematics Pathshala. This is a problem of CSIR NET December 2023 Mathematical Sciences. This is a problem of Abstract Algebra Part C. The question ID is 704088. This is a problem from Galois theory and field extension. So first we read the question. Let fx equal to x cube minus 2 belongs to qx, the polynomial ring over Q, and let K subset of C be the splitting field of Fx over Q. Let omega equal to e to the power 2 pi I by 3. Which of the following statements are true? So here omega is given by e to the power 2 pi I by 3. So this is nothing but actual, the definition of omega is we all know that minus 1 plus 2 3 I by 2, and this is actually this e to the power 2 pi I by 3. So we are given that a polynomial fx defined by x cube minus 2 and k is the splitting field of this polynomial. So clearly all the roots of this polynomial is, one is 2 to the power 1 by 3, one is 2 to the power 1 by 3 omega, and the other is 2 to the power 1 by 3 omega square. We all know that. This is a easy exercise in classical algebra theory of equation to find the roots of the equation like this fx equal to 0. Okay, so clearly if we write the splitting field of fx over q, that is k, so this will be actually okay. So for the simplicity, let us write u equal to this 2 to the power 1 by 3, then these three roots are u omega squared. So k would be actually our q omega square. So this is the smallest field containing containing q and these three elements u omega square, and this is nothing but q comma omega. So now okay, so we find what is our k now. Now just look at the options. Option 1 says that the Galois group of k over q, that is, we denote this by Galois group of k over q. So here k is a extension of k, extension field of q. So now Galois group of k over q. So this is given in option 1, that this is S3. Option 2 says that the Galois group of k over q omega is the symmetric group S3. Option 3 says that the Galois group of k over q is z by 3j, that is Z3. And option 4 says that the Galois group of k over q omega is z by 3z, that is Z3. So to solve this question, we have to find these two things. One is the Galois group of k over q, and the other is the Galois group of k over q omega. So the question is all about these two things. We have to find these two things. One is the Galois group of k over q, and option 1 and 3 are about this. This is for option 1 and 3. And the Galois group of k over q omega, this is in option 2 and 4. So these two things now try to solve with. So first see, we know that the Galois group of, if k is a field and if is the extension over K, then we know that the Galois group of F over K is equal to, we have F index K, that is the dimension of the vector space F over the field K, as F is a vector space over K. We can think F as a vector space over K. So for this here, we have to find this thing. So we have to find what is our Galois group of K over Q. So that is actually Galois group of, this is actually order of this group. So this equal to K is our here Q U omega over Q. So this is equal to our Q U omega. This is a field extension of Q. So the dimension of this vector space over Q, this, and this can be written as Q U omega index Q omega into Q omega over Q. This is easily we can write. So now clearly here the minimal polynomial of omega over Q is clearly x square plus x plus 1. So this will be 2 because this is a polynomial of degree 2, and the minimal polynomial of u over Q is x cube minus 2. So this is a polynomial of degree 3. So this will be 3. So this is 3 into 2 equal to 6. So now clearly the Galois group of K over Q is a group of order 6. So this Galois group of K over Q may be two groups. This may be either S3 or Z6 because there are only two groups of order 6. One is Z6, another is S3. So if possible, suppose it is Z6. So if possible, suppose that Galois group of K over Q is Z6. So now 2 divides this 6. So we must have, as Z6 is cyclic, so there is only one subgroup of order 2. That means there is only one subgroup of index 2. So there is only one subgroup of index 3 because subgroup of order 2, so it is subgroup of index 3. But we know that this K, that is Q U omega, contains three distinct subfields. One is QU, one is QU omega, and one is QU omega square, such that this QU over Q, the degree or rank of this vector space over Q is equal to, will be 3, and also this is equal to QU omega over Q, the degree of Q U omega over Q, and also the degree of Q U omega square over Q. So there are three distinct subfields such that this for these three subfields the rank of these vector spaces over Q are 3. So for these, each of these subfield there are subgroups. There are subgroups, that is for this we can write this Galois group of Q U over Q. This will be a subgroup of order 3. So this will be a subgroup of this Galois group of K over Q. And for this also we can write the Galois group of Q U omega over Q is 3. And for this the Galois group of Q U omega square over Q. So there will be three distinct subgroups of index 3. So these two statements simultaneously cannot happen, that there are three distinct subgroups and there are only one subgroup of order 2. So this cannot be Z6. So we must have Galois group of K over Q is actually equal to or isomorphic S3. So now look at the options. So for option 1 and 3 it is solved because the Galois group of K over Q is S3. So option 1 is the correct option and option 3 is not the correct option. Now look at option 2 for these 2 and 4. See here, from these things that Galois group of Q U omega over Q, that is K over Q, this order equal to this Q U omega over Q into this Q omega over Q. So now this is actually here 6 and this is actually, sorry, this is Q over Q omega. So this is actually K over Q omega into this is actually here 2. So we have this K over Q omega degree of K over Q omega is actually 3. So that means the Galois group of K over Q omega is a group of order 3. So it must be Z3 because there is only one group of order 3, that is Z3. So now look at option 2 and 4. We find that the Galois group of K over Q omega is Z3. So option 4 is the correct option and option 2 is not the correct option because it is said that it is the symmetric group S3. So option 1 and 4 are the correct options and 2 and 3 are not the correct. So this is the solution of this